So as with most things in the world of Hadoop, there's more than one way to solve the same problem. Let's talk about Apache Flume, which is another way of streaming data into your cluster for further processing. It's another way of handling the problem of how does all this data get into my cluster in the first place. And Flume's a little bit different in that it was made from the start with Hadoop in mind. So you can really think of Flume as a bona fide part of the Hadoop ecosystem, as opposed to Kafka, which is much more general purpose in its design. It has built-in sinks, we call them, things that can actually connect to write data into HDFS and HBase, as well as other systems too. And it was originally built to handle the problem of log aggregation. So specifically the problem of, I have a fleet of web servers that are fronting some massive website, and somehow I need to get all the data from those web servers' logs into one place on my HDFS Hadoop cluster. Now, you might think to yourself, why can't I just directly transfer data across to my HDFS cluster? Well, you need some sort of a buffer in between these two things because HDFS and Hadoop don't really like having a million things connected to it at once, writing to it at once. And with things like log traffic, it can be very spiky. There can be these big fluctuations in the data rates. And by introducing a system like Flume in the middle, you create sort of a buffer that lives between where your data is coming from and where you're storing it, so that if things start to get backed up, it won't bring down your cluster, and it gives things time to adjust and get caught up naturally over time. Now, when we talk about Flume, we talk about Flume agents. And a Flume agent consists of these three components: a source, a channel, and a sink. So basically, when you're setting up Flume, you tell it, I want to set up these agents that connect some data source to some place where I want to stick that data. And we can configure different types of sources and different types of sinks that might connect to different data sources or data destinations. So for example, we might have a Flume source as part of a Flume agent that listens for web server logs being dropped in the log directories on a bunch of web servers, that then can go through a memory channel or a file channel to transfer that information to a sink that might be configured to actually write that data into, in this example, HBase, or it might be HDFS or something else entirely. So there are three components of a Flume agent. One is the source, which again is where the data is coming from. And the source can have a few options on it as well. You can bolt on what's called channel selectors. So you can actually have logic attached to a source in Flume that says, well, based on what data I'm seeing, maybe I want to send it somewhere else. So you can actually have some logic there that says, data that looks like this goes here, data that looks like this goes somewhere else. And you can also have interceptors as part of your source, and an interceptor just can add or reshape the data that's coming in before you send it out. And we'll see an example of that later on. The channel is how that data gets transferred between the source and the sink. So there's basically two choices there. One is through memory, which of course is going to be the fastest way of doing it, or you can transfer through files. So if you want to make sure that your data is being transferred in a persistent manner, so if a Flume server actually goes down, it can recover from that, and it doesn't lose the data in memory, then you might want to consider files. But for most cases, memory is good enough, and that's going to be the fastest way of dealing with it. Finally, the sink determines where your data gets stored to, where your data is going. And you can have multiple sinks if you want as part of an agent. You can organize multiple sinks into sink groups. But the catch is a sink can only connect to one channel. So it's not really like Kafka, where Kafka just stores up data indefinitely and people can pull that data whenever they want to. I mean, Kafka does expire data after some amount of time, but with Flume, basically your sink grabs data from Flume, and once it's been grabbed from the channel, it gets deleted. So Flume does not hang on to your messages or your events, if you will, any longer than it needs to. As soon as your sink processes it, it throws it away. Okay? So that's one of the primary differences between Flume and Kafka. Kafka is a little bit more easier to set up if you have data going to multiple different places that might be pulling it at different rates. You can do that with Flume, but it's a little bit more tricky. Now, there are a lot of different built-in source types and sink types in Flume that makes developing with it pretty easy. Chances are whatever you need to do, there's already a plugin for it. So out of the box, Flume can monitor a directory for log files or any file that gets dropped into it and use that as a data source. It can also use the Avro format, which is basically a communications format that's specific to Hadoop. It can connect to Kafka as a source. It can connect to exec, meaning it can connect to the output of any command line prompt you might be running on Linux. Like you could do a tail-f on a log file and feed new lines that get appended to a file into Flume as a source. Thrift, like Avro, is another data connection interface that you can use to tie different agents together. Netcat can be used to actually listen to data being streamed in on any arbitrary TCP port. There's also an HTTP source type that just listens to web traffic. And you can write your own sources from scratch as well in Java if you want to. So if you need to do something else or integrate with some custom server, you can do that too. And there's more I didn't even talk about. Sync types, a wide variety built in as well. So you can write data to all of these different types of destinations, automatically write into some HDFS directory on your Hadoop cluster. You can write straight into Hive. You can write straight into HBase. And again, you can use Avro and Thrift as a data protocol to actually connect different agents together. You can also output directly into Elasticsearch, into Kafka, and again, you can write your own custom syncs as well to integrate into other systems. Something else you can do is by using Avro, we talked briefly about connecting one agent to another, and this is an example of where you might actually want to do that. So one of the powerful things about Flume is that you can set up these multi-tiered fan-in designs. So let's say, for example, you have a lot of application servers generating a lot of log traffic. Those might go to a first tier of Flume agents that are physically close to those servers, from a network topology standpoint. Because as you can see, those app servers are going to be generating a lot of network traffic as it dumps its data into these Flume agents. But then you can then have another layer here where those Flume agents on that first line of defense then consolidate things down to another tier, that has fewer Flume agents. And ultimately, that final tier is what actually writes into HDFS. So this sort of architecture can prove to be very scalable, first of all, because it limits the amount of network traffic and writes that are coming into HDFS directly at the end, and also because it lets you scale things a little bit more easily. So, you can scale this layer much more slowly than this layer, for example. And it also has benefits if you're dealing with things like multiple data centers. So you can make sure that parts of your topology that only have a few lines going into it are what's going across your wide area network, while areas that have a lot of traffic going on are being handled on a local area network within the same data center. So this sort of pattern gives you a lot of flexibility. The way this works is this first tier of Flume agents might be configured to have sources that talk directly to your app servers and monitor their files directly. But for these layers where an agent is talking to another agent, you would probably have an Avro sync set up at this layer and an Avro source set up at this layer to just allow that Flume agent to transfer data very efficiently to this next agent and connect these agents together using the Avro data protocol. And finally, that agent would have an HDFS sync in addition to an Avro source. So Avro is sort of the glue that can bind agents together. So think of Flume as a buffer between your data and your cluster. It's basically a way of smoothing out the traffic between the data coming in from your logs or whatever your source might be and where you're writing it to. If we go back and look at here, let's imagine that HDFS starts to get backed up. This Flume agent might start buffering things up, and if that actually got filled all the way up, then it would start pushing data back to this layer of Flume agents, and only until you actually got to a situation where this tier also ran out of room for queuing up events would you run into any trouble where the app servers would actually be refused connections to the Flume agents. So you want to make sure you design your Flume flows in such a way that you're unlikely to hit the overall limit of all these layers given any reasonable length of outage. So with all that, let's actually get our hands dirty with Flume. Flume is fortunately built into the Hadoop, to the Hortonworks sandbox environment, and it's just running by default, so there's nothing we need to do to spin it up or install it. We can just start playing with it. So we're going to do a couple of things, a couple of exercises here. The first thing we're going to do is set up a very simple example, and this comes straight from the Flume website documentation. And very simply, we're going to set up a flow with a single agent that has a source of Netcat. And Netcat just listens to a TCP port for data. So this means we can just connect via Telnet to some port and start typing in data and have that imported as a source into Flume. That will go through a memory channel and then be dumped into a logger sync, which does nothing but write that information out to a log that we can watch as it comes in. So that's going to be our very simple example to start out with, where we just telnet into our agent using a Netcat source, and we watch the output flow through into a log at the end of the day through the logger sync. After that, we'll do something a little bit more interesting, where we'll actually spool some log files, a real log file. We'll set up a spooldir source, and that just monitors a directory for new files that are dropped into it, and we'll drop a log file into it to watch it actually work. We're going to bolt on a timestamp interceptor to actually insert a header on that data that has the current time of when that data was dropped in. That will all get pushed through a memory channel again and go to an HDFS sync, which will configure not only to write that data again into an HDFS directory, but into a structure, a directory hierarchy that actually has the year, month, date, and 10-minute interval that data was generated within. So that's a scalable way of organizing this sort of a data and something you might see in the real world. So let's dive in and start playing around with Flume.